All right, I have been having trouble. This is my third video over the same thing, so we shall see how this goes. Hopefully this time it will work. So go ahead on page 99, try problem A, B, and C, and then I might just try writing it on like white paper instead of a screenshot of the book. So we'll see how that goes, but go ahead and try to find A, B, and C. Maybe I'll try a screenshot for this one and then try the paper for the other stuff. We'll see. But try problem A, B, and C on your own, and then I'll come back. Okay, so the first question here, let me find this. There we go. All right, is asking you to find the percent increase. And let me find my pen here. All right, I got things unhooking, all sorts of things. Okay, so let's look here. So just be a little cautious that 2014 is there and this is 2015 right there. So kind of if I draw the line that goes, well, maybe if I draw a line that goes to 14 and that goes there. Okay, so what percent? You know you're going to divide and multiply. And we're looking at the increase. So how did it change? So it went from 96 to 99, so that is a $3 change. And then you always divide by the start when you do percent increase or decrease, because you're trying to compare to where it was to where it's going. So it doesn't make sense to use where it's going to if you're comparing. So where it started it was $96. Again, units cancel, multiply by 100, so divide and multiply by 100, and you should get about 3%. Okay, so you always take the change divided by either the start or the beginning amount. Okay, so the next one. Forecast what you think it was going to be in 2016. So if Disney was 99 in the year, 2015, we could, think it's going to go up by 3%, figure out that, which rounds to about $3. We could add it to the original price from the previous year, and we could think like, oh, it's going to be about $102. A faster way of doing that would be to say, okay, well, it's $99. I know they're going to keep the price, and they're going to increase it by 3%. So that is a 103% increase. And you could write that. This is called a multiplier when you kind of combine it. And so then you can multiply. You'll still get the $102. You just don't have to multiply and then add. All right. And then the last question is asking, so overall, what was the percent increase from all of those years? All right. So I'm looking from at the beginning here. So in the year 2000, tickets were $40. All right. So let me go to blue here, I guess. So we're looking at, in this year, it was 40. And then over here, not 2016 though, 2015. All right, so what was the change? So again, change over the beginning or the start. So it looks like prices went up by what, about $59? And the start was $40. Now, if you just divide, you're going to be like, oh, it's a 1%, increase. Well, there's no way it's 1% because if you look, it's doubled, right? So it's over 100%. So when you divide, you still have to multiply by 100. Your units cancel, but this is going to be over 100%. And in fact, it's about 130%, right? Because the price, the increase is more than $40. So it's more than 100%. So make sure once you divide that, if you're converting to a percent, you don't forget this part. All right, so let's go. Why don't you go ahead and read the next page and then try problem number 2. And I'm going to pause. Okay, on the bottom of page 100, it says, what would your multiplier be for an increase of 22% and a decrease of 22%? So again, a multiplier is always 100% plus or minus your increase or decrease, percent, whatever it is, whichever one you're doing, and then you put it in decimal form. So if I'm increasing by 22%, I'd have 100%. I'm increasing by 22%. So that would be 122%. But in decimal form, that would be 1.22. So that's what I would call my multiplier. And what that does is it adds the 22% to it, so I don't have to do 2 steps. Multiplier when you're decreasing, 100%, subtract the 22%, means I'm only keeping 78% of the value. So my multiplier for that would be 78 or 0.78. All right. Read the next few pages, and we'll talk about the Excel stuff and the salary stuff later. I want you to jump to page 105, but read through that. Just don't have to worry about doing it. And I'll pick up on problem number 4 on 105. So try problem number 4 on page 105, and I'll be right back. Okay, so here it talks about 1.37. And it also talks about 0.51. And it says, what kind of multiplier is this? Like, what kind of percent change are you really doing with this multiplier? So you kind of have to undo the math here. So you have to think if this was a percent, it'd be 137%, which is 100% plus 37%. So this one's not too bad because you're kind of like, oh, they're increasing by 37%. So that's what that means. So this multiplier would mean an increase of 37%. This one, you have to think a little bit more because you would have 100% minus whatever the percent decrease is. And you're getting an answer that you're keeping 51% of the value. So you have to think to yourself, what am I really subtracting here? And so you're not subtracting 51%, you're subtracting 49%. So if you take the difference here, you get 49%. So this actually is a 49% decrease. So on increase, you can kind of just see it. Decrease, you can't see it. You got to do a little math and be like, okay, I'm keeping 51%. So if I'm keeping, say, 51% of the value, that means I'm losing the other 49%. And so this is what I'm decreasing by. All right. Go ahead on the same page, fill out the weight loss chart for the husband and the wife, and then go ahead and answer A, B, C, and D on page 105, and I will catch right up with you. Okay, so on page 105, kind of in the middle there, we have this chart. And so the first question in the chart is how much weight was lost. So you can subtract here and say, okay, well, he lost 14 pounds, right? And she lost 10 pounds. So he lost more. But the reason we do percents is to put things in perspective. So again, percent, you always take the change, divide by the start, always the beginning. So divide, multiply by 100, and you'll get a percent. So for him, it's about 3.7%. For her, again, change divided by the original, always, and multiply by 100, and you get her percent, which is about 5%. So remember, percent sometimes we call relative frequency because it puts it in relative terms. Yeah, he lost more, but he weighed more, you know, and she lost less, but she weighed less. So who really lost more weight, okay? And it kind of depends on what you're looking at. So if we look at A, the husband lost more pounds. Well, if we look, did the husband lose more pounds? Yes, he did. So A is correct. That's a correct answer. B, the wife lost a higher percentage of her weight. Well, if you look there, she did. She actually lost a higher percentage. So B. Okay, let's look at C. C says the wife's new weight is 95% of her original. So again, to use a percent, remember you always multiply. So I'm going to take 95%. It tells me of is multiply her original weight. Well, what was her original weight? 200 pounds, right? So if I multiply that, right, I am going to get an answer of 190 pounds. So that is actually true. So that one's true as well. All right, so let's look at D. D says the wife's starting weight was 5% more than her ending weight. So 5% more than her ending weight. All right, so let's look. Her ending weight is what, 190. Now, I could either do 5%, figure it out and add it, or I could do a multiplier of 105% because she's going to keep the 190, and then if I add the 5% on, right? And so if I take a calculator, right, and I get on my calculator here, what am I at? So I have 190 times 1.05, or if you do it in 2 steps, that's okay too. But multipliers are super helpful. So I get 199.5. So it's close to 200, but it is not equal to 200. So I can't undo the math that way. So D is not true. And I'll tell you why here in just a second. So, all right, let me erase this and let me kind of explain why that doesn't, why you can't just undo it that way. All right, so say that your boss is, say you have a job where, I don't know, they're going to pay you for the year and then maybe you take a pay cut. So say you make $40,000 a year and say you're going to have to take a 10% pay cut because of, I don't know, otherwise they're going to lay people off or whatever. So everyone agrees to take a 10% pay cut. So what that means is you're taking a 10% decrease. You're losing 10%, which means you're only keeping 90% of your salary. So you could do 10% and subtract, get it that way. Or if you want to use a multiplier, that's a lot faster, and you get $36,000. Okay. So say the next year, they're like, oh, you know what? We are going to give you a 10% raise to compensate, and life is good, and we'll get back to where we were. All right, but your new salary is $36,000. And so if you get a 10% raise on that, that would be a 10% increase. So you're getting 100% and 10%. All right. So if you take 36,000 times 1.1, your new salary is going to be 39,600. So it doesn't get you back to your 40,000. And so the reason percents don't do that is because when you're doing this percent forward, you're doing the math on 40,000. But then when you're trying to go back and add the 10%, you're going off a new answer. So it's kind of like your totals are changing here. So here, your new salary is this. So you're not doing the math on the same 40,000 that you were. Okay. The other thing to remember is if you're multiplying to get an answer, more multiplying is not going to undo it. So adding undoes subtraction, subtraction undoes adding, multiplying. So think about what undoes multiplying. So if you're multiplying going forward, more multiplication is not going to help you out. All right, go ahead and do number 6. Okay, so let's look at number 6, still on the same page, page 105. Okay, so a price of an item goes from $200 to $400. All right, so it goes from $200 and now it's going to $400. Okay, A. There was a 100% increase in price. So if you think about it, it was $200 and now it's worth another $200. So that is a 100% increase. The word increase implies adding. So here's 100%. We're adding another. So we add another 100%. So it is a 100% increase. So A is true. All right. So let's look at B. B says the new price is double the initial. Well, if you look, the new price, if I double it, or you can look at the picture, you can see it literally is double. That is also true. So doubling is true. All right, let's look at C. There was a 200% increase in price. Okay, so that the word increase implies adding. So you have the original, and it's a 200% increase. Well, 100% would be a $200 increase. 200% would be a $400 increase. So this would be a 200% increase. But notice the new price is not $600. So that one is not true. All right. D, the way this is worded, does not imply adding because it says the new price is 200% of the original. So it's not saying an increase. It's just saying it's 200% of it. So again, to use a percent forward, you're going to change it to a decimal, multiply by the original, which is $200, and you do get 400. So that one is true. All right, let's pause and do the last one. Okay, so number 7, it says that your college is going to increase tuition, each of these percents per year. Now, some people want to add percents. You can't do that because, for example, if I give you a 50% discount and you get a new price and then another 50% discount, you don't get the thing for free. It's not 100%. You're going to do the 50% first and get a new price and then do the 50% on that new price. So percents don't add. So what you need to do here is you need to take $100, just make up some tuition, 100's easy, and do all these percents. And when you multiply, you're going to get 149.45. And so if you think of percent change, it used to be $100. And now it's this. So if you take 49.45, divide by the original, that's why I strategically picked 100 and multiply by 100. It's really a 49.45% increase or decrease. You cannot just add those up. All right, so B, Think about the answer to that and then see.